Good afternoon, grade 12s. I am Andiswa Sifumbatikiso. I am a mathematical literacy educator, also chief examiner for mathematical literacy paper 1. Right, this afternoon we are going to share some tips to prepare you for the upcoming exams, as well as do some questions that will help you to prepare you for the exams, which we are writing on Friday. First of all, I want to say to you, you must make sure that whenever you receive your question papers, don't make a mistake of going through right to question 1. You must first read your instructions, read them thoroughly. That is very important, and you need to follow them. And then you must make sure that whenever you get into that exam room, you have all the equipment that you need, your rulers, your pencils, your calculators, because it's going to be frustrating if you go into the exam room and you don't have your calculator with you. Now you must borrow a calculator from another learner. So make sure that you have everything that you need. And it is also important that you read to understand your questions, even if it has to be 3 times. Read it again and again up until you understand what the question wants, because you get so excited sometimes you just hear one word and then you think that is what is needed, and you find out later on that it was not what you were supposed to be answering. So make sure that you read to understand the questions thoroughly. All the time, make sure that your units are included in your answers. In mathematical literacy, it is very important that you must always put your units at the end of the answers, and remember also to round off to the correct number of decimal places. There is an instruction every time in the paper that will tell you that you need to round off to 2 decimal places unless stated otherwise. So make sure that you round off to the correct number of decimal places. And it is also important as well to make sure that you use the marks as a guideline. I always tell my learners, if it is a 1-mark question, it is fine, you can just provide an answer. But immediately when it is more than 1, that means 2 and more, you need to make sure that there are steps involved, because there are marks that are allocated for the steps that you follow when you get to your final answer. Now, I also advise learners to convert if there is a question where you are given centimeters, maybe and meters. So it is important rather to first convert your centimeters to meters if your answer is supposed to be in meters before you can do your calculations. But otherwise, you must also stick to what your teachers have advised you. If you feel comfortable with doing the calculation and then converting later, that is also fine. When it comes to graphs, we observe that a lot of learners, they will draw the straight line graphs hand-free. That is why earlier on I said you need to make sure that you have your rulers available with you, because straight line graphs must be drawn using a ruler. Your bar graphs, your histograms, it makes your work look neat and it makes it easy for marking. And it is also important that you write neatly and legibly, because if your handwriting is not very clear, you end up forfeiting marks because you are not sure whether your 6 is a 0 or it is a 6 or something like that. Another important matter is to make sure that when you substitute, if there's a question where you need to do substitution, do your substitution correctly. Make sure that you don't change the signs. For instance, you are given a plus, some of the learners will change that plus to a multiply, and it is not supposed to be done like that. So make sure that you keep the formula as it is, do your substitutions, and then work on your answers. Now paper 1 is the paper that consists of level 1 and 2 questions. That means this is where you have to score the most marks. You must make sure that when you go into that exam room on Friday, you are readily prepared for the paper. You must collect as many marks as possible, 150 over 150 if possible, because you don't know what to expect in paper 2. In paper 2, like I said, paper 1 consists of level 1 and 2 questions, and paper 2 consists of level 2, 3, and 4, which tends to be a bit demanding for other learners. So do as much as you can to collect as much as you can in paper 1. We still have time before the end of the year as well, and you still have today and tomorrow to go back to your educators before you get into the exam room. So whenever there is a problem or things that you're still struggling with, make use of your educators. They are there for you. Go back to them, and you must make sure that you practice as much as you can. And you also need to make sure that you start with the question that you are most comfortable with. It makes better sense to say, if you are comfortable with question 3, you would rather answer question 3 before you answer question 6. So as long as you indicate at the top of the page that this is question 3, and then the other next questions and so on, it is not going to be a problem. Start with the questions that you are comfortable with, because you want to collect as many marks as possible. And whenever you go to that exam room, make sure that you are comfortable, you are calm, and you are prepared, and everything will go smooth. And you must also make sure that you revise your June exam papers, both paper 1 and 2, the common controlled tests that you wrote this year, starting in March, as well as the test that you wrote on the 26th of August. Go back to those tests, revise using them as well. You must also use old past question papers. They will also help you to prepare well for this paper. So now we are going to start with the first question, and the first question consists basically of calculator problems. And on your screen there you can see we are starting with question 1, and your question 1 consists of 1.1. And starting right away with question 1.1, let us have a look at 1.1.1. We are supposed to do the following calculations, and as the instruction says there, show all calculations in full. If you look at 1.1.1, it consists of 1 mark. As much as it consists of 1 mark, we still have steps that we can follow there for us to write that 47% as a common fraction. Now I know that you have done a lot of these questions through the year, so we are going to start with that question 1.1.1, where you're supposed to write 47% as a common fraction. Now, when we write anything as a fraction, you need to make sure that we have a numerator and a denominator. But in grade 12, you also know that you cannot just leave your answer. You need to make sure that you simplify your fractions. So starting with that 47% as a common fraction, let us go right through it. You need to write your 47% as a common fraction. So what do? You know that when we have that percentage sign, this actually means you need to write as 47 over 100, and that means we are now getting rid of the percentage sign. Now if you get rid of the percentage sign, even if with this one, even if you do your calculation on the calculator, you'll see that you still remain with the same answer. So in this case, there's not going to be a difference. Your answer will remain 47 over 100. So our answer stops right there. Now we will go on to the next question, which is 1.1.2. And 1.1.2 requires you to write 78 over 120 as a decimal fraction. Now what is a decimal fraction? A decimal fraction means there must be a comma. And because of the calculators that you are using, they make it easy for you, because you click in your calculator and it will give you the correct answer that you are looking for. Now let's go through it. We have 78 over 120, and it gives us a 13 over a 20. But what are we looking for here? A decimal fraction. Now, how do we get to a decimal fraction? If you are using a Casio, you just press your SD button and it will give us a 0.65. So that is what you are supposed to get in the second question there, 1.1.2. Going on to the next question, 1.1.3. We have to simplify 1.2 meters is added to, between brackets we have 23.5 meters multiplied by 5. You close your bracket and you minus 4.7 meters. In this question, learners, we have to follow the BODMAS rule, And the Bodmer's rule says we must first remove the brackets. And when you remove the brackets, you'll have to divide, multiply, add, or subtract. I always advise my learners that before they can remove the brackets, they must first solve what is inside the bracket. So I'll also advise you to do the same. We can bring down the 1,2 meters as it is, and then inside the brackets we have a 23,5, multiply that by 5, and it gives us 117,5 meters. Remember units? I said earlier on, your units are very important. And then the next thing is, now we can follow the Bodmer's rule. If we remove the brackets, we can see that next to this bracket we have a plus sign. So it is not a multiplication sign, we are not going to multiply. In other words, we can actually bring down 1,2 meters plus 117,5 meters minus the 4,7 meters. Now we have removed the brackets. There is no division. We don't have a multiplication sign in this step. So the next thing that we need to do is to add before we can subtract. And then we go to 1,2 meters plus 117,5 meters. It gives us 118,7 meters. Remember your minus 4,7 meters. So we can go through that as well. Minus 4,7, and it gives us 114 meters. So our answer in this case is 114 meters. Now I'm aware that maybe I'm following long steps, but it is to make sure that even learners that cannot go through this, maybe don't understand some of the steps, they are able to follow through with me. Let's go on to the next question, 1.1.4, where we have to simplify 1 over 3. Multiply that by, between the brackets we have a 3 to the power 3 outside, plus square root of 64. Now this question gives you a 3 marks. So it is important that we have steps in there as well that we include before the final answer. I would advise that we can bring down the 1 over 3 as it is, the multiplication sign. But in this step we need to solve what we have there between the brackets with that cube and the square root of 64. So you can check this with your calculator, but 3 to the power 3, it means we have to multiply 3 times, and that gives us a 27. We can check in our calculator. We get a 27 plus the square root of 64. The square root of 64 is 8, but let us just check that. We get our 8. Now remember, this is also a Bodmer's calculation. So now that we have our third multiplied by 27 plus an 8, we have to first multiply before we can add. Remember, Bodmer says multiply before we can add. So we can multiply the 1 over 3 with 27, and it will give us a 9. Then we bring down the plus 8, and then when you add there your answer with 8, it gives us a 17. So your correct answer there is 17. We move on to the next question, 1.1.5. In 1.1.5 we have to calculate 14% VAT on 24,650 rands. We have to calculate 14% on 24,650 rands. Now when we have to calculate a percentage, it means we are going to multiply this what we have with the 24,650. So we will put the 14 over 100, because that is how we calculate our percentage. We multiply it by 24,650. We go to our calculator. Our answer gives us 3,451. So that is our 14% of 24,650. I don't know if you have noticed, I've been including my units, and if you can look at the numbers, we always group them in threes. That is why there's a space between the 24 and 650. That is why we have a space between the 3,000 and the 451. So make sure that you also group your numbers in groups of 3. It makes it easy for you even to read your numbers. Let's go on to the next question. 1.1.6. 1.1.6 requires us to convert 1,500 rands into euros, and we are given the conversion there that we must use. The conversion of 1 rand is equals to 0.11 euros. Now, I always advise my learners to say, if you are given such a problem, you must first look at the conversions that you are given. If as we are given now, our rands are representing 1, you know most anything divided or multiplied by 1 stays the same. So rather, let us not use the 1 rand, because anyway, whether we multiply the 1,500 by 1 or divide it by 1, it will still stay the same. So let us use this, the euro, which is 0.11. Now you look at your units. We have now the euros, because this is what we are going to use. We also have the rands for the 1,500 rands. Now what you are going to do is you use these as your clues. If your units in this case are not the same, then we are going to multiply. Only if our units were the same, then we would divide. But in this case, we are going to multiply because our units are not the same. So we will multiply that 1,500 rands with 0.11 euros. If we go to our calculator, 1,500 rands multiplied by 0.11 gives us 165. Now, what is this 165? We were told, remember, to convert the rands to euros. So our answer is in euros. Remember to include your units every time. Let us go on to the next question. 1.1.7. In 1.1.7, we must increase. Now, you know when we increase, we add. So we are going to do some adding here. We must increase 1,250 by 24%. Remember, I told you earlier on, you must stick to the methods that your teacher has taught you, or the methods that you are comfortable with. What is nice about Maths Lit is you can use your method, but if your method is correct and you get the same answer as we get, then your method is correct and you get your full marks. So you don't have to worry about that. Now, I know that other learners would first say 24 divided by 100, multiply that by 1,250, and then calculate that. 24 divided by 100, multiply that by 1,250, we get 300. So remember, it's 300 rands. So we can then now say we will take this 300 rands and add it to, remember we were told to increase, and I said increase means we must add. We will add that to 1,250, and that will give us 1,550. Other learners may use another method of deciding to say our 1,250 represents 100%, so we will now add, because we have to increase this 1,250 by 24%, they will add the 24%, and this will give us 124%. Now, the next step will then be 124 divided by 100, just like we did there, but in this case we have already added with the percentages. We multiply that with the 1,250. Let us punch that in our calculators and see. You can see we get the same answer. So you can use any method. that you are comfortable with, which will give you the correct answer, and you stick to those methods. Going on to the next question, 1.1.8. We have to calculate the number of 30-gram portions of jam that can be obtained from a 450 grams tin. Now let's see. Here, fortunately, our units are already the same, so we don't have to change any unit in this case. Now, if we have to find out how many 30 grams can we get from a tin of 450 grams, remember earlier when we were calculating or converting the rands to euros, I said if units are the same, we can divide, but if units are not the same, then we need to multiply. But in this case, the units are the same, so we are going to divide. We will then say 450 grams divide by 30 grams. As you can see, our grams will cross out because we are looking for the number of times that the 30 grams can go into a 450 gram tin. Let us check that in our calculators. See how much we get. We get an answer of 15. So it shows that we can get 15 times 30 grams in a 450 gram tin of jam. Let's move on to the next question. 1.1.9. In 1.1.9, we are supposed to determine the cost of 6 bus tickets using the formula. Now we are given a formula, so we must stick to the formula. Cost of bus ticket is equals to the number of bus tickets multiplied by 12 rand 15 cents. Now this is a long one. May not be clear for you on the screen or there. We can get it through. Right. We have to calculate the cost of a bus ticket. And the formula is number of bus tickets multiplied by 12 rand 15 cents. If you go back to the question, it also says there we have 6 bus tickets that we must calculate. So if the cost of 6 bus if the number of bus tickets are 6, then it means that is the number that we are going to substitute in the number of bus tickets, because we are told there it is 6, so we will multiply that 6 by 12 rand 15 cents, punch that in our calculators, we get 72 rands 90 cents. Remember your units. So the cost of 6 tickets will be 72 rands 90 cents in this case. Let's move on to the next one. Question 1.2. Jane participated in a sponsored 20-kilometer walk to raise funds for AIDS orphans. The organizer encouraged the walkers to have a 15-minute rest during the walk. The graph showing the distance covered by Jane against the time taken by her is given below. We see there we have a graph, and it shows the time taken for 20-kilometer walk. We have on our vertical axis the distance covered in kilometers, and on our horizontal axis we have the time of day. As we can see, the time started at 7, it goes through right up to 10:30, and the distance starts from 0 to 20 kilometers. Now looking at 1.2.1, with this one we are not going to use a calculator, we will just read all the information from the graph. 1.2.1 says we must, at what time did the walk start? Now if you look at your graph, like I said, on your horizontal axis we have the time of day. It shows clearly there our graph, our graph starts at 7 o'clock. So it shows that the walk started at 7, because you can see immediately after 7, it was not at 0 anymore. So our answer for 1.2.1 is 7 o'clock, just as it appears there. Now I know some of you will say 7 a.m. and so on, but our answer is 7. 1.2.2. How many kilometers did Jane walk during the first hour? Now, if you start counting from 7 o'clock and you have to add an hour, the time puts us to 8 o'clock. Now, looking at the graph, we need to go right up using that 8 o'clock time, straight up until we meet the graph, and then we will be going across to the left to see the distance that will be covered in that first hour, because the question requires us to check how many kilometers did Jane cover in the first hour. And from 8 o'clock going across to our left, you can see that Jane traveled or walked a distance of 6 kilometers. So our answer there is 6 kilometers. Going through to the next one. I'm sure this is easy for other learners because they can easily read the graphs. 1.2.3, how far had Jane walked by 10 o'clock? Now we can see the times on our horizontal axis, but we will have to again go up the graph up until we meet the graph, so that we can go across to the left to see how far, because far means distance. How far had Jane walked by 10 o'clock? If you look at our graph, when we go up the time 10 o'clock and going across to our left, as you can see, our units or our scale is of 0.5, although it doesn't show there. You just get your 1, 2 up to 20, but you can see that it is in units of 0.5 is the distance in kilometers. So if you go to your left, you will see that Jane walked 16.5 kilometers by that time of 10 o'clock. So Jane walked 16.5 kilometers at 10. And the next question, 1.2.4. How long did Jane take to walk the first 9 kilometers? If they say how long means the time. So it means we have to now look at the time. The time is most portrayed on our horizontal axis, but we have to look at our vertical axis to get the 9 kilometers. We go right across to our right from 9 kilometers up until we meet the graph, and then when we meet the graph, we will go down to determine the time that the time of day. That will give us the time that Jane walked in the first 9 kilometers, that it took Jane to walk the first 9 kilometers. And as you go right across up to the graph, when you go down, you get to 8:30. So, but that is not our answer. Remember, the question was how long. Now, it means from 7 o'clock up to 8:30, we have to calculate the time there. How much time do we have between 7 and 8:30? And the answer there is 1 hour, 30 minutes. So it took Jane 1 hour, 30 minutes to travel the first 9 kilometers. 1.2.5. After how many hours of walking did Jane rest? Now we will go back to our graph. Let's go back to our graph. And you'll see that the place where Jane rested, it is represented by that straight line. You'll notice that the kilometers are the same, but the time goes. Even if Jane rested, time still went on, but the kilometers were not added up because she was resting during that time. So we have to now look at our graph and determine after how many hours of walking did Jane rest. Remember, Jane started walking at 7 o'clock, and it looks like from the graph, Jane rested at 9 o'clock. So it took Jane how many hours of walking for her to rest? It took Jane 2 hours, because from 7 o'clock to 9 o'clock, we get a difference of 2 hours. So our answer there is 2 hours. Moving along to the next question, 1.2.6, which is the last one in question 1. Give an estimate of the time at which Jane finished the walk. That means we have to go back to our graph so that we can give the estimate of time at which Jane finished her walk. And if we go to our graph, we can see that she didn't take up to 10:30 because our graph does not meet that 10:30 line. So it means she finished her walk just before 10:30. Hence, it is said give the estimate of the time she finished walking. But then let us also use the bars that we have there as a guideline. Between 10 and 10:30, there's a line in between. So that line can guide us to say it is 10:15. It represents 10:15. Now in this next bar between the line and 10:30, it means we have 15 minutes. So giving an estimate, we must rather be too close to 10:30 than being too close to 10:15, because it cannot be 2:17. But if you say 2:28, 2:27, 10:27 or so, it makes sense, because we can see that it is just a few minutes before 10:30. So perhaps your answer can be anything between 10:25 to 10:29. So your answer can range within 10:25 and 10:29, because it cannot be 10:30. At 10:30 she had finished her walk. Now we will move right along to question 3 of the same paper. This is also one type of a question that a lot of learners do not like, LO3, but it will be assessed, and it has been assessed during the year. So you must prepare very well as well for this question. Using the information that we are given there, it says Jabulani is learning the skill of welding. He decides to make a money box out of a rectangular sheet of metal that is 40 centimeters by 30 centimeters. In 3.1, we are required to calculate the area of the thin sheet of metal. We are given a formula that we can use. Area is equals to length multiplied by breadth. I'm sure even if you are not given a formula there, you'll be able to remember the formula itself. Now remember, we are told that the measurements of this rectangular sheet are 40 centimeters by 30 centimeters. Now if we go to our formula, which is area is equals to length multiplied by breadth, and we substitute the information that we are given, I'm sure you cannot find L in your calculators, so that means we must remove the L and replace it with something else, as well as the B, but we can find the multiplication sign. So the multiplication sign will come down exactly as it is. And then in the place of the length, as we were told, the metal sheet is 40 centimeters by 30 centimeters. Now I know some of you would be saying, but you told us to write neatly and legibly, and now my cm there is not very clear if it's centimeters, but it's supposed to be centimeters. Let us punch those in our calculators. 40 multiplied by 30, it gives us 1,200. But now we have to multiply as well our centimeters, and it will be centimeters squared. So our answer there is 1,200 square centimeters. So the metal sheet is taking an area of 1,200 square centimeters. We're moving on to question 3.2. Jabulani has a choice of a rectangular or cylindrical money box as shown alongside. The cylindrical money box has a radius of 6 centimeters and a height of 15 centimeters. The rectangular money box has a breadth of 8 centimeters, a length of 15 centimeters, and a height of 15 centimeters. All this information is also shown in the diagrams. Now, some of you maybe will be making notes whenever you get the information to try and fit things where they fit in, but we have to use all this information that we are given, and it will guide us to find the correct answer. If you look at question 3.2.1, we are told to calculate the surface area of the circular money box, and we can use the formula. Surface area of a cylinder is given by the formula 2 pi r multiplied by the height. You close your bracket, plus open your bracket, 2 pi multiplied by your r squared. And we are also told that we must use pi as 3,14. So we are going to use pi as 3,14. So wherever we see pi, we must substitute it with 3,14. Let us go back and substitute. We must open the bracket as the formula is indicated, and we can find a 2 in our calculator, so we will replace that with a 2. In the place of pi, remember we are told we must use pi as 3,14, so I'll open a small bracket there and substitute the 3,14. We multiply that by, now we go back again to our question. Remember, all this information is given in our question. What was the radius again? We are told that the radius is 6 centimeters of this cylindrical box. Now that means we will substitute 6 centimeters. We multiply that. Let's go back to the question. What is the height of the cylinder? The height of the cylinder is 15 centimeters, meaning we will substitute 15 centimeters there for the height. We can close our bracket. We have an addition sign there that will bring down as it is the opening bracket, the 2. Another small bracket for our pi. Remember, pi must be used as 3,14. We can close that one, multiplied by our radius. We have substituted earlier on a radius as 6 centimeters, so we will substitute again 6 centimeters. But remember, in this case, our radius is squared, so we must also square that. Before we can remove the brackets, it is advisable that we can first solve this in this first bracket, as well as this 2 and 3,14, as well as the 6 squared in the second bracket. Then we'll be able to multiply everything. So multiplying 2 with 3,14, it will give us 6,28. Let us just double check that. 2 multiplied by 3,14 gives us 6,28. We multiply that by 6 centimeters. We will also multiply that by 15 centimeters. We can close our bracket. Let us also solve the second bracket. The second bracket, again, it will be 6,28 multiplied by 6 centimeters squared, means we must multiply 6 centimeters twice, and that will give us 36 square centimeters. We can check that in our calculator. It gives us 36. Now we can multiply everything as it is inside the 2 brackets. Starting with the first bracket, we have 6,28. We will multiply that by 6, multiply by 15, and our answer is 565,2. Remember, we have centimeters and centimeters, which we must also multiply, and they will give us square centimeters. Fortunately, in this question, our units are all the same, so we don't have to worry about that. Let's move on to the second bracket. We have to multiply 6,28 with 36, and that gives us 226,08. 226,08. Remember your units, square centimeters. It is possible for us to add those two because the units are the same. I think in lower grades we used to say they are like terms. So we are able to add them, and our answer is 791,28. Remember the units, square centimeters. Our answer is already in a form of 2 decimal places, as instructions would normally say, and there was no special instruction in this question where they said maybe we must round off to the nearest unit. So our answer will stay 791,28 square centimeters. We will move on to the next question. Okay, before we move on to the next question, I think it is just important to remind you that whenever you are given such formulas, you must never change the formulas as I have indicated earlier. You take the formula as it is, you go back to the information that you are given, and with the information that you are given, it will definitely tell you where the length is, or how much the length is, the height, the radius, the breadth, and so on. So you substitute where you are supposed to substitute. And you must also remember that the multiplication signs and the addition signs that are used in your formulas must stay as they are, because sometimes you find learners changing those signs, and sometimes they give you a star, and I don't know whether we can really calculate using a star. But you must make sure that you use the same multiplication signs wherever you see multiplication signs, and so on, so that you can get to the correct answer at the end of the day. And we will take a short break, and after the break we will go on with 3.2.2. Right, welcome back, grade 12s. We will continue with the exercises that we were working with. Question 3.2.2. We have finished calculating question 3.2.1, where we were supposed to calculate the surface area of the cylinder. And in question 3.2.2, we have to calculate the surface area of the rectangular money box. So we are again going to use the given formula there, which is 2 multiplied by the length multiplied by the breadth, plus between brackets 2 multiplied by the length multiplied by the height, close your bracket, plus 2 multiplied by breadth multiplied by the height. Now we are working with the rectangular box, money box, and we are also given the measurements there. Remember, our height is 15 centimeters, our breadth is 15 centimeters, and our length, no, the length is 15 centimeters and our breadth is 8 centimeters. Sorry about that. Now let's go back and look at the calculations. There. We are given the formula, so we need to substitute there. I hope you can still remember the measurements. Remember, our length we were given as 15 centimeters, so we will substitute 15 centimeters, multiplied by our breadth is also 15 centimeters. No, sorry, the breadth is 8 centimeters, plus we have 2 multiplied by the length of 15 centimeters, multiplied by the height is 15 centimeters. So the length and the height have the same measurements. 2 multiplied by, remember our breadth is that one of 8 centimeters, and our height again is 15 centimeters. Okay, that is not so clear there, but in the next line we will make it clearer. Now we can multiply everything that we have inside that bracket. As you can see, everything in there is multiplication, multiplication, so we are allowed to calculate everything inside the bracket. So we will multiply 2 multiplied by 15 multiplied by 8, and that will give us 240. But we must also remember we have centimeters and centimeters, so we need to multiply them, and they will give us square centimeters. This is basic knowledge that you learn from grade 9 or even the lower grades, I'm sure. and then we multiply again between this bracket. We have 2 multiplied by 15 multiplied by 15, and we get an answer of 450. Again, centimeters multiplied by centimeters give us square centimeters, plus, I know the last bracket is not clear, but it is 2 multiplied by 8 multiplied by 15, and that gives us another 240. Remember your units, centimeters multiplied by centimeters, they give us square centimeters. So we can see that all our units there are square centimeters. That means it is possible for us to add all of those answers of the 3 brackets. So we will add 240 plus 450 plus another 240, and we get an answer of 930 square centimeters. So it shows that the rectangular money box has a surface area of 930 square centimeters. Let us look at the last answer in this question. The last question in this question 3.2, which is 3.2.3. It says the volume of the circular money box. We must calculate the volume of the circular money box, and we must use the formula volume of a cylinder is given by the formula pi r squared, or radius squared, multiplied by the height. And again we must use pi as 3,14. Let us also just look at our measurements once more. If we are going to substitute in this formula, we are going to need a radius as well as the height. Now the radius we are given, it is 6 centimeters, and the height is also given, it is 15 centimeters. Now let's go back to where we are doing our workings. Let's substitute in the formula. Remember, pi must be used as 3,14. So we will substitute there 3,14. We multiply that by our r. We were given as 6 centimeters, and it must be squared. And then our height is 15 centimeters. Before we can multiply that whole thing, I would advise that we can bring down the 3,14 down as it is, so that we can solve the bracket, the 6 squared. And 6 squared means 6 multiplied by 6. The same with the centimeters, it will give us 36 square centimeters. And then we will also bring down the multiplied by 15 centimeters. Let us punch our numbers to get our answer there. Our answer is 1,695,6. Now remember, we have now square centimeters and centimeters to the power 1. What are our units going to be? They are going to be cubed. Remember, volume is always cubed. I always tell my learners to differentiate this way, because you find other learners confusing the units of the perimeter, the area or surface area, as well as the volume. It depends on the units that you are given, but you must always remember that if your units are centimeters, with perimeter your units will always be to the power 1, or as we have written it here, it will just be centimeters. But our area, with the same units, because it is 2 sides, it will always be squared. Area and surface area will always be squared. And as for the volume, your units are always cubed. So remember that. Even if you are not sure, but if you can remember that perimeter is to the power 1, area is squared or surface area, and your volume is always cubed. We will move on to the next question. The next question is question 4.2. Another one which is not a favorite to most. In question 4.2, we are told that Mr. Ravi decided to pave the rectangular driveway in front of his garage. The length of the driveway is 10.35 meters and the width is 2.99 meters. We have the picture there of the driveway. A rectangular paving brick has a length of 23 centimeters and a width of 11.5 centimeters paving bricks. Paving bricks are sold in pallets of 354. In the pictures that we are also given there, we can see we have a picture of the paving brick. We have a worker that is paving the driveway, as well as a pallet of bricks. In this question, we are required to calculate the minimum number of pallets that must be purchased in order to pave the driveway. Now, whenever you want to pave a driveway, it is always advisable that you must buy only what you need. Otherwise, you'll buy too much and you end up spending more than what you need, or otherwise you buy too little. So it is important that you do your calculations before you can do the paving. Hence, we are following this formula. We are also given here the formula of area of a rectangle is equals to length multiplied by breadth, which I'm sure we all know. Now, we have to calculate the minimum number of pallets. It's going to look like a longer type of a question because we have a lot to calculate for us to get the number of pallets. But what is important is for you to note that the driveway, the length is 10,35 meters and the width is 2,99 meters. This is now for the driveway. And we also have the bricks, the paving bricks. We are told that the paving brick, the length is equals to 23 centimeters and the width is equals to 11,5 centimeters. Now we must find out how many bricks are we going to need to pave the driveway and convert that to the number of pallets. If you notice, our units here for the bricks are in centimeters, and for the driveway they are in meters. So I would advise that in this case we must convert our units of the brick to the meters so that we can work easier with that. Now remember, I said to you, you must use the methods that your teachers have taught you. I have another one of some people will call it King Harry died a miserable death called measles. It makes it easier for you to remember. So people like me who are not 100% Afrikaans speaking, it also makes you remember better when you say Kyk hoe die man die sente maak. I don't know if that is correct Afrikaans. I don't know what it means really. But in any case, you can follow this method, and when we go to this direction, we have to divide. To that side, we multiply. Now we want to change centimeters to meters, so we will put a 1 on our centimeters, moving on up until we find the meters, because the K can stand for kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. But now it's changing from centimeters to meters, so that means we are going to divide. Now if we want to change 23 centimeters, and from this it tells that we must divide by 100. If you punch that in your calculator, you'll find that your answer is 0,3 meters. So it means 23 centimeters is actually 0,23 meters, pardon me. That is now for the length of the brick. Now coming to the width of the brick, our width is 11,5 centimeters. Because it is also centimeters and we are trying to change it to meters, we are again going to divide by 100 and we will get a 0,115 meters. You can also check that through your calculators. Your width will be 0,115 meters. Now we can calculate the area of a brick, area of the paving brick. Remember, we were given a formula of area is equals to length multiplied by breadth. So we will follow the same formula, but now we are calculating the area of the brick. So we will substitute those values of 0,23 meters multiplied by 0,115 meters. Let's punch those in our calculators. If you punch the numbers in your calculator, 0,23 multiplied by 0,115, it gives you 0,02645. Remember your units, there's also meters that you must multiply with meters, and it gives you square meters. Now I would advise that in this case, because we still have some calculations to do not round off yet. in that stage. I know you are told to round off to 2 decimal places, but we can leave it there so long. And then we can calculate the area of the driveway. Remember, the objective is to find out how many bricks will we need for the driveway. We use again the formula length multiplied by breadth, and the measurements for the driveway were 10.3 meters multiplied by 2.99 meters. Let's punch that in our calculators. We get an answer of 30.797. Remember, your units meters multiplied by meters, they give us square meters. So in this case, or at this stage, we can now divide, take the 30.797 square meters, which is the area of the driveway, remember, divided by the area of each brick, which is 0.02645 square meters. This is what is going to help us to get the number of paving bricks, hence the square meters, and the square meters will now cross out. Let us punch this in our calculator. 30.797 divided by 0.02645. Our answer is 1,164.347826. Remember, this is now the number of paving bricks. I'm sure you will agree with me that there is no way that we can have 1,164.34 paving bricks. We cannot work with commas. You don't buy a comma brick, a comma 3 brick. So we are going to round this off, and it will be 1,164. Actually, we round up 1,165. Sorry, because we have to round up, not round off. Now, we must also remember, we were given the information that each pallet consists of 354 bricks. Now, if a pallet consists of this number of bricks, we need to know how many of these can we get in this number of bricks so that we can place an order for the number of pallets that we need. So we can actually just divide that by 354, 1,165. Divide by 354 bricks. We get an answer of 3.2909 and so on and so on. But now, like I said earlier, we cannot buy half a pallet of bricks when you buy a pallet of bricks. So it means we will have to round up because you want your driveway to be completely paved. So that means we will buy 4 pallets. And that is our answer for question 4.2. We continue with question 4.3. It is a continuation of 4.2. It says, Mr. Ravi has to hire a truck to deliver the pallets of bricks. ABC Transport charges a set fee of 95 rands plus an additional charge of 5 rand 45 cents per kilometer if the distance is more than 10 kilometers. So that means if the distance is within 10 kilometers, you are not charged an extra fee, you only pay 95 rands. But if you stay away with more than 10 kilometers, so it means it's going to be an additional cost to you because you'll also have to pay an extra 5 rand 45 cents per kilometer. Now in 4.3.1, we have to write down the equation that ABC Transport uses to calculate the delivery charge of the bricks in the form delivery charge is equals to. Now, we are told in the information that there's a set fee of 95 rands. So immediately when you go to ABC Transport and you tell them you need to hire their truck, they will charge you a 95 rands, which will then be added to, depending on the number of kilometers, an extra 5 rand 45. So that means we have this 95 rands as a set fee. So immediately when you go to them, you have to pay this one if you want to hire their truck. So it will be this 95 rands added to we will open a bracket so that we can indicate inside the bracket that there's an extra 5 rand 45 cents per kilometer if more than 10 kilometers. In other words, somewhere here we are going to subtract. If we have more than 10 kilometers, we will have to subtract, and whatever answer that we get there, we must multiply by 545, because remember, there's an extra charge if you stay for more than 10 kilometers away from where they have to deliver. And that is all that was needed in 4.3.1. Moving on to 4.3.2, they say Mr. Ravi lives 35 kilometers from the brickyard. His friend offers to deliver the pallets of bricks at a cost of 250. Might sound cheap, but let us see. Indicate, showing all the necessary calculations, whether he should use ABC transport or take up his friend's offer. So the first thing that we will have to do, because we already know that the friend is offering him a deal of 250 rands. Now we have to first find out how much will ABC charge him, so that we can then compare whether he must take the friend or whether he must go with the ABC transport. With the formula that we already have, I'll just say DC. In our formula, they're standing for delivery charge for ABC transport. Remember, there's a set fee of 95 rands plus the 5 rand 45 multiplied by, I'll open another small bracket because we here now Mr. Ravi stays 35 kilometers away, but we must minus 10 kilometers because you only start paying extra if you stay at a distance that is more than 10 kilometers. So it will be that 95 rand that will bring down as it is. Between the brackets we have, 5 rand 45 cents multiplied by 35 minus 10 kilometers. Remember, this is within the brackets. I know some of you are saying now, what about BODMAS? This is within the brackets, so we must first solve what is inside the bracket, and we get 25 kilometers. So that means Mr. Ravi will pay for 25 kilometers, not for the whole 35. We can punch in the 5 rand 45 cents multiplied by 25 kilometers. We get an answer of 136 rands 25 cents. We will add this to the 95 rand set fee, and we get a total of 231 rand 25 cents. Now what do you say? ABC transport charges 231 rand 25 cents, and the friend offered 250. So it is obvious that you will take the cheaper one, or the most economical one. Right, moving right along. We will now quickly look at question 5.2 of this question. I hope it is clearer. We are only going to look at 5.2 in this one, as well as 5.3. Question 5.2 says, Tembeka compared the monthly salaries of the employees at 2 call centers, one in Greyton and the other one in Johannesburg. The following are the monthly salaries in rand and by call center agents. You can see there we are given the salaries of people working at Greyton, 4,200 rands and so on. And then we are also given the salaries of people working at Johannesburg. In question 5.2.1, we are required to calculate or to determine the range of the monthly salaries earned at Greyton agency. Now when we calculate the range, what do we look for? We look for the biggest number as well as the smaller number. So the range is actually the difference between the bigger number and the smaller number in that set of data. Looking at the salaries at Greyton, you can see that the biggest amount or the biggest salary is 7,200 rands. 7,250 rands. So like I said, the range is the difference between that bigger number and the smaller number. So the bigger number is 7,250 and your smaller number there is 4,200 rands. Let us then calculate our range. So we will take the bigger one, First, we subtract the smaller number, which is the 4,200 rands. We punch this in our calculators to get our answer. And we get a difference of 3,050 rands. So the range in this case is 3,050 rands. Then the next question. Write down the median monthly salary earned at Gr.12 agency. Now, what is a median? A median is the number that is in the most middle. After you have arranged your numbers in an order, it can be from the lowest to the highest or from the highest to the lowest. But in this case, if you look at the salaries of Gr.12, they are already arranged in that form. So we must just look for the number that is in the most middle. And with these salaries that we are given here, we can see that there's 9 of them. So that means we'll take 4 in the lower half and then another 4 in the upper half, and we will be left with one number in the middle, and the number that we have in the middle is 4,650. So that makes our median to be 4,650. There isn't really a calculation here, because it is just for us to be able to determine the median from the data. And you can pick it up that the number that is in the most middle is 4,650. Now 5.2.3, it says calculate the average or the mean. Other people call it the mean, other people call it the average. We have to calculate the average monthly salary earned at Johannesburg agency. For us to get the mean, we are going to add all those salaries and then divide by the number of entries, and it will give us the mean. Let us do that. We are going to add all those numbers. It's 5,550, 5,500 plus 5,525 plus 5,980 plus 6,250 plus another 6,250 and another 6,250 plus 6,300 plus 7,800 plus 8,200 plus 8,900. Remember, we will divide that by the number of entries. And how many salaries do we have there? We have 10 of them. So we will divide that by 10. Now let us punch all of these numbers in our calculators to see how much we get. 5,500 plus 5,525 plus 5,980 plus 6,250 plus 6,250 and another 6,250 plus 6,300 plus 7,800 plus 8,200 plus 8,900. Our answer is 66,955. 66,955, we divide that by a 10 and we get an answer of 6,695 rands 50 cents. So that means this is our average salary at Johannesburg. Now I want us to move on to question 5.3. Question 5.3 says Tembeka invested 6,350 in a savings account so that she would have enough money to pay for her move to Johannesburg. The amount was invested at an interest rate of 5.8% per annum compounded annually. And now we have to calculate the final amount that Tembeka will receive after 2 years. We are given a formula of A is equals to P into 1 plus I to the power n, where A is the final amount, which is what we will be calculating. P represents the amount that is invested. I is the interest rate, and N is the investment period. Let us go to the calculation. I've briefly summarized what we are given there. This is the amount that she wants to invest, which is our P. So we will substitute it in the place of P, the 6,350. We open our bracket, 1 plus, what is I? Remember the difference between I and R is that with I, whatever it is that we have is divided by 100, and R, we have a percentage sign. And because our interest rate is 5.8%, we are now going to change it from R to I so that it is 5.8 divided by 100. We are now getting rid of the percentage sign. We close our bracket because the formula requires us to close. And what was the period? It is 2 years, which is our N value. So we substitute there with a 2. We will bring down the 6,350 as it is so that we can first solve what is inside the bracket and then multiply with the exponent. Then we can multiply with the 6,350. We can still bring down the 1 plus so that we can first solve that 5.8 divided by 100, and it will give us 0.058. So we substitute there the 0.058 to the power 2, 6,350. We open a bracket, 1 plus that 0.058 will give us 1.058, and our exponent is 2. Let us again bring down the 6,350. This means we must multiply this 1.058 2 times. So we will square it as the exponent says there. So our answer gives us 1.119364. I hope you get the same. Now we will multiply that answer of ours with the 6,350. And our final answer is 7,107 rands, 96.14. But now, as you can see, we will have to round off to 2 decimal places. Yes, there was no special instruction, but the general instruction says round off to 2 decimal places. Even if you were not told this is money, in South Africa we only have 2 units after the comma when we talk about money. So our final answer is 7,107 rands, 96 cents. That is when we round off. And that was question 5.3. I also want us to just have a look at the final question here that I have prepared. Question 6. It says here, Luc van Wyk is originally from Mafikeng. He is now a student at the Central University of Technology, Free State, in Bloemfontein, and lives at the university residence. In 6.1, Luc uses a map to help him travel around the city. We will move on to the map just now. A map of Bloemfontein is printed on Annexure B, which we will have a look at. We must use the map to answer the following questions. So we must first, for 6.1.1, find or write down the grid reference for the National Museum. Let us move on to the map. Scrolling down. You'll also realize that in our map we don't have the numbers 1, 2, 3, and 4, but we will start counting from the left-hand side going to the right-hand side as 1, 2, 3, and 4, those blocks. We are only given the alphabets there, A, B, C, D, E, and F. And down there, you will see that we are also given indications. We have the Nelson Mandela Drive, but we are not looking for that. We have an arrow that goes to the National Museum, which is what we are supposed to look for. Let us just go where the arrow stops so that we can see where is it. There you can see just a bit above the word city there, and it is in the D block. But if you start counting from your left to right, you'll see that it is at D2. So the grid reference for the National Museum is at D2. So we write our answer there as D2. Unfortunately, we have to do this moving around like this. 6.1.2, it says Nelson Mandela Drive is a one-way street or traffic flows in one direction only. We must write down the two names of other one-way streets where the traffic flows in the same direction as the traffic in Nelson Mandela Drive. So if we go to our map, you can see they also show us, maybe I need to zoom in. I don't know if you can see my cursor there. Nelson Mandela Drive is going to that direction, and it is more like southwest direction. So we have to find two other streets that go to the same direction as Nelson Mandela Drive. It can be anywhere on the map. It doesn't really have to be a street that is closer to Nelson Mandela Drive. Let us look for all arrows that are facing southwest. Doesn't look very clear to you, but we also have Maitland Street. I don't know if you can also see that. That is one of the streets that have the same direction, Maitland Street. We also have, even if I zoom in, it doesn't make it very clear. I'm sure you are also having the same problem as I am having here. But it is this street there where you can see there's Avenue or Lan. Pitt Avenue or Lan next to it. Might not be very clear to you. So the two streets that we can identify now is Pitt Avenue as well as Maitland Street, that have the same direction as Nelson Mandela Drive, going southwest. Let's go back to the question. You will also realize that there are no calculations done here so far, because we just have to identify the streets. Let's go back to our questions. Now we go on to question 6.1.3. It says here, the entrance to Luke's University residence is in St. George Street. We must use an extra B and describe the shortest route that Luke will travel by car to the Ramblers Club, the entrance of which is in Zastron Street. Now I'm not going to go back to the map right now, because as you saw earlier, the map is not very clear. Even when it's enlarged, the writing on it becomes dimish. So we are not going to go back to that. But what I want to advise you is, whenever you are giving directions, you must never use words like up and down, or words like up and down don't work. You need to give directions in terms of right or left, or south, north, east, or west. Those are the directions that you must use. So perhaps you would be saying turn right at this street and turn left at this street, or turn east at this street. That is how you are supposed to be answering such questions. Whenever you give directions, we only use the right and the left, or we can use the directions of north, south, west, northeast, and so on. We go on to question 6.1.4. Now we are going to do some calculation here. Question 6.1.4. It says Luke went for a walk. When measured on the map, the distance he walked measures 7 centimeters. That is now the distance on the map. Calculate the actual distance in kilometers. He walked, if the distance he walked in kilometers if the scale on the map is 1:20,000. Now what does the scale mean? The scale means if we are talking about centimeters, 1 centimeter on the map represents 20,000 centimeters on the actual ground. So we are given here the distance that he walked, and they said it measures 7 centimeters. So the 7 centimeters must now be converted to kilometers. That is what the instruction is saying. Let us go to the calculation and see what we are supposed to do. I've already written down the distance that he walked on the map, and we are having a scale of 1:20,000. That means if we are going to convert the centimeters so that we get our answer in kilometers, we are going to take this 7 centimeters, which was the distance on the map, and we will multiply it by 20,000. Remember I said 1 centimeter on the map represents 20,000 centimeters on the actual ground. So this will give us the exact distance on the ground. We multiply then 7 by 20,000, and we get an answer of 140,000. But what is this 140,000 centimeters? It is the actual distance on the ground, but our answer is in centimeters. And the instruction said we need to calculate the actual distance in kilometers. I don't know if you still remember, earlier on I introduced you to Gr.12, man. The center mark, or King Harry died a miserable death called measles. This K representing kilometers, the M representing meters, and the C representing centimeters. And that is actually where we are right now, because our answer is in centimeters. So that means we are going to start counting from the C. We put a 1 on the C, and as we go along up until we reach the kilometers, we just keep adding zeros, because this is going to guide us as to how, with what amount must we divide. As you can see, we are going to that direction. So that means this 140,000 centimeters, we will divide it by 100,000, because this number there gives us 100,000, so that we can get our answer in kilometers. Let us punch the numbers in our calculators, and we get an answer of 1,4. But remember now, our answer is in kilometers. So the actual distance that he traveled is 1,4 kilometers. And at this stage, grade 12s, we have come to the end of the activities that I have prepared for you. I do want to say to you, we wish you all the best, and we hope that today's session has helped you, and that it will also help you for the final exams as well. Remember all the tips that we shared with you right at the beginning of everything that you need to do when you get into the exam room, to remain calm, to start with questions that you think you can perform better than in others, as long as you indicate the question number on top. And you must make sure that you follow the instructions as they are. You must also make sure that you read and understand the questions thoroughly, and make sure that you also show the steps that you have taken to get to your final answer. We wish you all the best, and we hope that you are going to practice as much as you can. Remember, luck has nothing to do with anything. If you don't study, you are hoping that luck will help you. It will not help you, but you need to dedicate yourself. Make sure that you study as much as you can, you practice as much as you can, and immediately on Friday after writing your paper 1, of course you will have to rest, but immediately as soon as you can, after resting there, you must start working on your paper 2. Good luck. Thank you.